Good morning, everyone. I'm up before the rest of my family to try and record this, so if they get up and start running around, things will get noisy. I wanted to say hello, check in, make sure you guys are doing okay, and this is our second day of distance learning as we close our first week of the school shutdown. Before we begin, I would remind you that your mental health and your health overall is of greater priority than our education at this moment. That knowing about our polygons is secondary to being healthy enough to actually communicate that information to somebody else. So in this time, please be sure that you are taking care of yourself, that you are taking minutes. I've posted several links in Classroom, hopefully to help you still mentally reset and be able to proceed forward in this time that is kind of strange and chaotic, unprecedented, as the news is very keen on saying. Our math content today is going to focus on quadrilaterals, that is four-sided, quad being four, lateral being side, so quadrilaterals are four-sided figures. This is a pretty natural extension to all of the work that we did with triangles being three-sided and some of the other things we needed to pick up with circles. So as we foray more into our polygons, our many-sided figures, we're just taking a one step up to look at the different definitions and classifications of quadrilaterals. By the end of today, you should be able to complete the next 3 assignments on Khan Academy that have to do with classifying quadrilaterals and identifying, and I think the last term was analyzing. Now, it is very possible to talk about quadrilaterals and probably get through the assignments simply with your 4th grade knowledge of what our shapes are, squares and kites and trapezoids and rectangles. But when it comes to raising this to the high school level, what we're really going to be looking at and focusing on are the definitions of these things. What are the minimum qualifications it takes to be one type of object or another? In that regard, the reasoning that you need to have, the reasoning that you should be able to apply at the end of this section, is akin to the statement, all thumbs are fingers, but not all fingers are thumbs. So we're thinking through the idea that a thumb is a finger because it's part of your hand, but there are other fingers that we don't name thumbs. As a side note, remember that because this is a digital format, because this is a video, you are welcome to pause this at any point in time to take care of whatever else you need to, or to copy things down if you learn by writing, if that's part of what helps you connect yourself to the knowledge. In fact, I would encourage you to write things down if you have access to paper. It's one of the reasons why I'm back in this written format instead of trying to do everything digitally, because there is a different connection that is made that way. And as we breach this learning online gap, it may help for you to try and connect the two, for you to actually write things down as you're watching, because we're in, again, an unprecedented situation. So about this first quadrilateral, I'm starting with the one that's kind of odd. It's called a kite. It's defined by having 4 sides, of course, because it's a quadrilateral, and 2 pairs of adjacent congruent sides. Not all 4. You can't have all 4 being the same and still be called a kite. We'd call that something else, which I'll get to in a moment. There's also a special kind of kite called a dart, which is a concave kite. So in this case, all darts are kites, but not all kites are darts. As far as the properties of kites go, this goes back to our whole triangles bit, because again, we can break up each of these bigger objects back into those triangles, which is again why we spent so much time on triangles before. If we draw the diagonals, connecting the vertices, the corners, all the way across a kite, we end up with 2 different isosceles triangles. And that means that through some of our ASA and side angle side and all that other good stuff, along with CPCTC, we get the following properties. The diagonals will always be perpendicular bisectors. Sorry, no, that's right. The diagonals are simply perpendicular to each other. They intersect at 90 degrees. And the opposite angles, the angles across from each other in this quadrilateral, will be congruent. So I've marked our 90-degree intersection as well as the pairs of angles that will be the same because we have those isosceles triangles again. The next figure to mention is a trapezoid. A trapezoid has only one pair. In math terms, the word is exactly one pair of parallel lines. And in math, this term exactly means one and only one, as opposed to common speech where we might say at least one when we say it has one. So trapezoids have only one pair of parallel sides, not possibly two. Those are different names, and we'll get to those in a moment. In terms of properties of these trapezoids, you should be aware that oftentimes we will want to think about these quadrilaterals as a rectangle and a triangle or triangles. We have a specific type of trapezoid called an isosceles trapezoid when the legs are the same, very similar to an isosceles triangle that has exactly two sides that are congruent. An isosceles trapezoid has only two sides that are congruent. And oftentimes when we start to look at these in terms of area or formulas or manipulating these shapes, it's good to consider this as a rectangle, a shape we're very familiar with even though we haven't specifically covered it again this time, and a triangle or triangles. When we talk about properties of isosceles trapezoids, it is also good to note that those angles are going to be the same, the ones that I have marked in that dark purple on either corner. This is a following of the isosceles kind of idea where we had with isosceles triangles that if the sides were the same, the angles opposite are the same. The same kind of idea happens here with isosceles trapezoids. Beginning the last pair family group of quadrilaterals, we have a parallelogram that has two pairs of parallel sides. In case you forgot the notation, those single arrows and double arrows on the edges do mean that those lines are parallel. In terms of numbers, that means those lines would have the same slope and equal value for the slopes and would, if extended, continue on side by side forever. So our parallelogram is made of two pairs of parallel sides, two pairs of parallel lines. So looking at the way these are grouped, we could then look at squaring out the corners or edges, vertices, angles in this parallelogram, and that would give us a rectangle. So a rectangle is defined as a parallelogram that has a perpendicular angle. Of course, because these are perpendicular, that does mean that all four angles must be 90-degree angles. So in terms of what's what, this means that all rectangles are examples of parallelograms, and I have defined this as a rectangle is a parallelogram that has an additional thing. It has perpendicular 90-degree angles in it. So all rectangles are parallelograms, but not all parallelograms are rectangles. Our next shape is a rhombus. This is not a subset of rectangles. It's not contained or related to rectangles, but it is related to parallelograms. A rhombus is a parallelogram that has four congruent sides. So as a parallelogram, it means that we have two pairs of parallel sides, and additionally, those four side lengths are the same. So the last quadrilateral in this section is the love child of a rhombus and a rectangle. It is a parallelogram, as always. These are everything in this group, they're parallelograms. It's a parallelogram that has four congruent sides and 90-degree angles in it. So every square is a rectangle because it's a parallelogram that has 90-degree angles in it, but not all rectangles are squares because not all rectangles have 4 congruent sides, just 2 pairs of congruent sides. Similarly, every square is a rhombus because every square has 4 congruent sides, but not all rhombuses are squares, rhombi, because not all rhombuses have 90-degree angles. Speaking briefly about the properties of these things, what you should know about rhombuses or a rhombus is that each of the diagonals will be perpendicular to each other. About rectangles, you should know that the diagonals are congruent length and bisect each other. So that means the square gets the properties of both, that the diagonals of a square are perpendicular bisectors to each other. Back to our parallelogram, we have our alternate interior angles and congruency things going on to be able to say that the angles that are across from each other will be the same, congruent. So in conclusion, we have a bunch of different things that classify as quadrilaterals. The only qualification for quadrilateral, the most general form, is that it's a closed shape with 4 sides. This splits into 3 major groups: trapezoids that have only 1 pair of parallel sides, parallelograms that have 2 pairs of parallel sides, and kites that have 2 pairs of adjacent and congruent sides. Each of these does go further down as it gets more specific. That does mean that every lower object has the same properties as its parent. So for instance, a rhombus is a parallelogram, which is a quadrilateral. So that tells me that it has 4 congruent sides because it's a rhombus, 2 pairs of parallel sides because it's a parallelogram, and in general, 4 sides in a closed object because it is a type of quadrilateral. The types of quadrilaterals mentioned here are trapezoids with its more specific isosceles trapezoid, parallelograms that split into 2 groups of rhombuses and rectangles depending on whether the sides or the angles are all the same, and then those 2 are combined to make the square where both the sides and the angles were all the same, and kites that have 2 pairs of adjacent congruent sides. Those are sometimes called darts if they are concave, although that's not a commonly used term. We'll generally deal with the convex forms. And if you were to jump to the other side of the pond, you might find that trapezoids are called trapeziums, which may show up depending on what other kinds of resources you decide to look up in Google. You might very well pull some information on the same stuff from the other side of the world. So again, remember to take care of yourself in this time, to stop, breathe, pause the video, write things down, try different things. Google other information. The topic is quadrilaterals again. Hierarchy may also be a word that you see thrown in there. In fact, your additional assignment, the one more thing I would like you to do besides the straightforward Khan Academy practice, is to Google hierarchy of quadrilaterals and find one of those family trees that shows that containment that we've been talking about, that most critical link to the thinking that should be developed in a high school geometry instead of just the names and facts about the shapes that you would have seen back in 4th grade. This much information should be able to take you all the way through the assignments on March 26th, through the quadrilateral angles and the review and the classifying and identifying. Which means these last 2 current assignments for the 27th, I'll be making a different video for shortly. Take care of yourselves. See you soon.